Educational GMAT. Your partner in your GMAT journey.
This might be slightly tricky. I'll give you guys 5 minutes for this. When fully burned, when fully burned. Slightly tricky to understand. All right, let's understand this. There are two types of fuel that are being discussed here. Which are those two types? Natural gas and propane, right? Natural gas. So now what is BTU? You don't need to worry about whatever it is. It's obviously some unit of heat. So natural gas, essentially 1 cubic foot of natural gas produces this much heat, and 1 cubic foot of propane produces this much heat. Fair enough? For a furnace in which either natural gas or propane may be burned as fuel, the efficiency of a given fuel. Now, this is kind of important here. How is the efficiency defined as? Efficiency of a given fuel. And mind you, we have two fuels here, natural gas and propane. How is, for example, efficiency of natural gas, right? How is it defined as? Usable heat produced, right? So this is usable heat produced when the fuel is burnt, in this case when natural gas is burnt in the furnace, expressed as a percentage of the total heat produced when the fuel is burned, right? Divided by basically total heat produced by natural gas and express it in a percentage. So this is what the efficiency of that particular fuel is. So in this case, the efficiency of natural gas would be usable heat that is produced when natural gas is burnt divided by total heat. And mind you, total heat is already given, right? Natural gas total heat is 1000 BTU per cubic foot. And total heat produced by propane is 2500 BTU. So again, not going into scientific terminology, and that's not important. So what it's basically saying is, just from an understanding perspective, that while natural gas produces 1000 BTU of heat per cubic foot of oil, per cubic foot of fuel, but when you are, let's say, using it for cooking, for example, right? Obviously, there would be some wastage, right? So out of 1000 BTU, if you are able to use only 800 BTU for cooking, then the efficiency of natural gas would be 80%, right? 800 divided by 1000 into 100. So that's basically how efficiency is defined. Are we clear so far? Okay. Now, this obviously some person who will purchase a furnace. So mind you, we are talking about efficiency here. So Kaiser will purchase a furnace whose efficiency with respect to either natural gas burned alone or propane burned alone is 90%. So Kaiser wants that, or rather, the furnace efficiency is 90%, irrespective of whether natural gas is used or propane is used. In both cases, the efficiency is 90%. Now, in the table, as in this table, select for natural gas cost per cubic foot and for propane cost per cubic foot. Select for natural gas per cubic foot, which is this, and for propane cost per cubic foot, propane cost per cubic foot, basically select for this column and for this column the values that are jointly consistent with the information given. This is the information that is given, for which, and what is the constraint here? Fuel cost per BTU of usable heat energy produced by this furnace would approximately be the same for each fuel burned alone. Did you get the question? Did you get the question, guys? Because this is not easy to understand. The question is not easy to understand. Solution is easier, actually. What do we have to select? We have to select a value for this column and a value for this column, for which the fuel cost per BTU of usable heat energy produced by this furnace would be approximately the same for each fuel burned alone. Each fuel as in natural gas and propane. Yeah, these are the two fuels. Simplistically speaking, what this is asking for is that among these given options, what should the cost of natural gas be, and what should the cost of propane be, so that the fuel cost per BTU of usable energy produced is approximately the same whether natural gas is used in this furnace or propane is used in this furnace. Yes, think about it. Now, this is given to us, obviously, right? Efficiency is given to us, right? That efficiency, how is efficiency defined as? Notice this is where the efficiency is defined as usable heat produced when the fuel is burnt in the furnace divided by total heat. And total heat, anyway, we are given 1000 BTU and 2500 BTU for the two fuels expressed as a percentage, so into 100. That's the definition of efficiency, correct? Okay, now I'll give you guys a couple of minutes. Think about how we would proceed here. What is the goal? What is the goal, guys? The goal is that among the given options, we have to identify a value for the cost of natural gas and a value for the cost of propane, so that fuel cost per BTU of usable heat energy produced by this furnace is the same for natural gas and propane. So what we can do is, obviously, since we have to find out the cost, right, of natural gas per cubic foot and cost of propane per cubic foot, what we can do is, let's start with assuming that natural gas costs $X per cubic foot of fuel and propane costs $Y per cubic foot of propane. All right. Usable, now notice, usable heat energy cost is what we want to equate, right? Usable heat energy produced is what we want to equate. And how is usable heat energy produced calculated? Using this formula, right? Now, if we look at this, let's start with natural gas. Obviously, whether it is natural gas or propane, Kaiser wants the efficiency to be 90%, correct? So then 90, right, for natural gas, right? 90 would be what? Usable heat energy produced by natural gas, right? Usable heat energy produced by natural gas when natural gas is burned in the furnace divided by what? Total heat energy. What is the total heat energy produced? Sorry, 1000, right? Natural gas produces 1000 BTU of heat divided by 1000 into 100. Correct? So, in other words, usable heat energy produced by natural gas is how much? 90% of 1000, right? So, this is what this represents. Usable heat energy produced by natural gas is 90% of 1000 BTUs. Similarly, what would be the usable heat energy produced by propane? He wants the efficiency to be 90%, and propane produces total heat energy of 2500 BTU. So usable heat energy produced by propane would be how much? 90% of 2500. Are we clear so far? Okay. So now notice, can you, given this information, right, given these two pieces of information, can you tell me what will be the cost per BTU of usable heat energy when using natural gas? Notice natural gas. All right, I am just considering natural gas right now. These many BTUs, right? 90% of 1000. These many BTUs cost how much? In fact, let me write it. These many BTUs cost $X. So 1 BTU would cost how much? Think about it. Think about it. Let's take an example. All right. A parallel example. If 100 BTUs cost $1, let's say, then 1 BTU would cost how much? 1 by 100. Correct? Same logic. If 90% of 1000 BTUs cost $X, then 1 BTU would cost how much? X divided by this quantity. See, same thing, right? 100 BTUs cost $1, so 1 BTU would, this is basically the classical unitary method, right? 100 BTUs cost $1, so 1 BTU would cost 1 by $100. These many BTUs cost X dollars, so 1 BTU would cost X minus, X divided by these many BTUs. So X divided by 90% of 1000. Similarly, now let's come to propane. Propane, again, notice 90% of 2500 BTUs, these cost $Y. So 1 BTU would cost how much? 1 BTU would cost how much? Obviously, $y divided by this, right? So $y divided by this. Now I think we are almost done, guys. This is the cost of usable heat energy, correct? Cost per BTU of usable heat energy when using natural gas. This is the cost per BTU of usable heat energy when using propane. But then what do we want? This cost of usable heat energy should be the same. Whether Kaiser is using natural gas or propane, right? Since we want the fuel cost per BTU of usable energy to be approximately the same for each fuel burned, uh, and hence we equate this. This is equal to this because that's the goal, right? So now if you look at it, this is not difficult at all. Uh, Notice that 90% would cancel, right? So what we get is y is equal to 2.5x. Incidentally, this obviously is x, this is y. And what do we want? For the cost, fuel cost per BTU of usable heat energy to be the same, what we've arrived to be the same, what we've arrived at is y should be 2.5 times of x. Are we clear? Okay. Now, can you tell me, uh, here we have to look at the given options. Suppose that, notice this is x. If x is this, if x is this, right? What should y be? See, if x is 0.0035, what should be y? 2.5 into 0.0035, correct? This is where you could use calculator if you wanted to, and let me do that. In fact, mind you, you would have access to calculator for the data insights section. So 2.5 into 0.0035 gives us 0.00875. Do we have an option? No. So which means this cannot be the value of x. All right. Okay. How about this? If x is 0.007, then y would, all right, 0.0070. How much are you getting, Dhanush? 0.0, 0.01, 0.0175. Oh, it's there. Yes. So notice 0.0175. So notice clearly x is this and y is this. Because these two values of x and y are consistent with the information provided. So basically what we are saying is, right? Yes. So essentially what we are concluding is that if the cost of natural gas per cubic foot is 0.007 and the cost of propane per cubic foot is 0.0175, then the usable energy produced by this furnace would cost the same, irrespective of whether you use natural gas or propane. That's the whole point. Are we clear? Now, see, for this question, I think some of you would already have noticed this. Kaiser wanted the efficiency to be the same for both the fuels, right? So it's 90% for natural gas, 90% for propane. And this got cancelled. So then whether it was 90% or 80 or 50 or 40 would not have mattered. because in either case it would have gotten cancelled for both. So this would have mattered only if Kaiser had wanted different efficiencies for natural gas and propane. Only then this would have made a difference. In this case, since it's the same, it just gets cancelled, right? So it's really as simple as x by 1000 is equal to y by 2500, right? So which means y is equal to 2500 divided by 1000 into x, which leads us to 2.5x. So y is equal to 2.5x. That's how we are getting. Friends, are we clear? Do we have any doubt on this? So the solution is not as complex as perhaps interpreting the question statement itself is.